The following isotopes do not occur naturally, but are produced in nuclear reactors. A. Phosphorus-30, B. Technetium-97. How many protons, neutrons, and electrons are there in a neutral atom of each of these isotopes? Let's start with part A and focus on phosphorus-30. Notice the number 30 next to phosphorus. What does that 30 represent? Yes, it's the mass number, which is the total number of neutrons and protons combined. But how do we find just the number of protons? Exactly, the atomic number tells us the number of protons in an atom. Think of it like the address of an element. It tells you exactly where it lives on the periodic table. For phosphorus, the atomic number is 15, meaning there are 15 protons. If phosphorus has an atomic number of 15, how many neutrons does phosphorus-30 have? There are 15 neutrons because the mass number, 30, includes both protons and neutrons. Subtract the 15 protons from the mass number, and you're left with 15 neutrons. Now, why is it important that the atom is neutral? In a neutral atom, the number of positive charges must equal the number of negative charges to balance out. So how many electrons does phosphorus-30 have? Correct. Phosphorus-30 has 15 electrons, the same number as the number of protons. Now that we've broken down how to find the number of protons, neutrons, and electrons in phosphorus-30, let's talk about the big ideas behind solving these types of problems. First, remember that isotopes are atoms of the same element with different numbers of neutrons. The key numbers to focus on are the atomic number, which tells us the number of protons, and the mass number, which tells us the total of protons and neutrons. By subtracting the atomic number from the mass number, we can find the number of neutrons. Second, in a neutral atom, the number of protons equals the number of electrons. This balance is crucial for understanding the atom's overall charge. Let's take a quick peek at part B to check for understanding. How many neutrons are in a neutral technetium-97 atom? Electrons? Yes, it is 54 neutrons because a mass number, 97, minus the atomic number, 43, is 54 neutrons. Since there are 43 protons, there must be 43 electrons to balance the charge for a neutral atom.